Alright, welcome. This is Pre-Calculus A. We're solving systems of equations in two variables. Okay, in other words, you're given a simple a simple equation that has an x and a y, or a y and a z, whatever letters you want to choose. It just has two of them. Okay, so some simple methods that you could use. You could use substitution. You could use elimination or graphing or matrix solution. Okay, so substitution. I don't think I need to explain this too much, but substitution, you basically solve for one variable, you plug it into the other equation, and you just continue to solve off of there. Okay, elimination, you pick one variable, you eliminate it by either multiplying to get some opposites, and you just kind of work your way down. We've done this so many times in Algebra 1 and Algebra 2. I'm not going to go into it too much. Graphing, I do want to show Desmos and how much it helps out. Okay, so for example, let's say your equation was y equals 3 halves, you got to move over the x minus 6. Okay, so let's say it was this equation and 2x minus 2y equals 5. Okay, so you could do elimination, you could do substitution. I like graphing because guess what? That's my answer. You have to remember, when you're solving a system of equations in two variables, when you graph it on a coordinate plane and they intersect at one point, that point is your answer. So for example, the solution for these two systems of this system of equation with these two equations is 7 equals x and y equals 4.5. And if I plugged it in and checked it, it would give me two true statements. Okay, so that's very helpful when working with this stuff. Okay, now if I had to solve a inequality, let's go back. If I had to solve an inequality, just like last time we talked about, I would have to look for the overlap. Okay, so let's go greater than. There we go. Okay, alright, now the best thing to do is to get the same color and go lighter colors. They just make your job a whole lot easier. Okay, so obviously the entirety of this answer would be everything underneath. Now if we're talking about inequalities, we would not include any answers on the line. Okay, so if you had to test a point, and let's say you had to test the point 0, -25, you would not get a true statement for either one of these. You wouldn't even get it for the true line it was. However, if we tested out the point let's say 4, 0, you would get a true statement for both of these inequalities and just work it across. Okay, alright, so that's pretty much it. Matrix solution, now this one you would need to take your let's just write one. 2x minus 5y equals 9, and negative 3x plus y equals 10. Okay, first off, you need to transform this into a matrix. Okay, so that's the fun part. So you would transform it into a constant or a coefficient matrix, a variable matrix, okay, and then you would have the answer matrix over here. Okay, so I'm going to call this capital C, this one's going to be capital V, and this one's going to be capital A. Okay, alright, so if I put my numbers in, I would have 2, -5, -3, and 1. My variables would be x and y, and my answer would be 9 and 10. Okay, alright, so C times V equals matrix A. Alright, now in matrix math, if I wanted to get matrix V alone, which is the whole point because I want to find out what x and y are, I would need to multiply by the inverse of C. So C inverted times C times V equals, and if I do it to one side, I have to do it to the other side. Okay. Now, what happens is that these two don't cancel out, but they actually become the identity matrix, which is just those ones with all the zeros and stuff. Okay. All right. Now, anything times the identity matrix is itself. So what we end up with is the variable matrix all alone, and that equals the coefficient matrix inverse times the answer matrix, and you have your variables. It's really simple how that works that way. Okay, I'm going to go to a calculator, and some of you guys might recognize this. If you've been around long enough, you'll know this is the first calculator I fell in love with. Oh wow, meta calculators become different. Matrix calculator. We want this one. Come on. Okay, there's also statistics calculator in here. It's really cool. And apparently it's taken a little bit longer. Oh, there we go. Okay, and I'll shrink it down a little bit so you can see it. Okay. Alright, so first off, pay attention to the fact that our matrix is a 2 by 2, so it's 2, -5, -3, 1. It's 2 by 2. And our matrix, okay, it's going to be rows, so it's a 2 by 1. And it's going to be 9, 10. Okay, so what I'm going to do first is I'm going to find the inverse of this first matrix, and I get this, and that's a pretty ugly looking thing. And then what I'm going to do is I'm going to rewrite over it 7, 6, 9 -0.3846. This one's going to be -0.2308, and this one's going to be -0.1538. Okay, now that I've now taken the inverse matrix and I put it back in here, this is the inverse of matrix A. This is the answer matrix. This is the inverse of the coefficient. All right, and if you pay attention to what I just did, we want to multiply those two. Okay, so we go ahead and multiply those two. We're going to take now matrix A times matrix B, and if you've been in Algebra 2, you know that's just a pain in the butt to do by hand, but there we go. We get a kind of an approximate answer. Now that's going to be an approximate answer until you double check it and just work with it. And you can actually double check it by using Desmos just to graph it out and stuff, but this is actually how you do the matrix calculator portion. Okay? Alright. That concludes everything for solving a system of equations in 2 variables. If you have any questions, give me a call on substitution or elimination. Graphing and matrix is what I just covered today. So if you have questions on the other 2 methods, please give me a call. Otherwise, you should know that by heart because you had to do it a whole bunch in Algebra 1 and Algebra 2. All right, thank you guys. Have a great day.